In this video, we'll look at how to find the derivative of an inverse trig function. This is the same standard that we've used the last few days for finding the derivative of inverse functions. However, the way that we find the derivative of the inverse trig functions is quite a bit different than the way we have found the derivatives of inverse functions over the last 2 days. So today we'll be using the chain rule applied with the formula for the derivative of an inverse function. And this will allow us to find the derivative of an inverse trig function. So today we're focusing on how to find the derivative of functions that contain sine inverse of x. At -1 and the exponent means inverse. This is not the same thing as taking the reciprocal. An alternative way to write sine inverse of x is arcsine of x. By putting the arc in front of the sine, that means inverse. Cosine inverse of x. Or you could write that as arccos of x. Tan inverse of x, or arctan of x. Secant inverse of x, or arcsecant. Cosecant inverse of x, or arccosecant. And finally, cotangent inverse of x, or arccotan. So let's look at how to find the derivative of sine inverse of x. So we begin with the problem. Y is equal to sine inverse of x. Since we don't know how to directly take the derivative of sine inverse of x, we can use a trick here. If we take the sine of both sides of the equal sign, notice on the right side you have sine of sine inverse of x. These are inverse operations that cancel each other out. And the right side of that equal sign will simplify to just what's inside of the sine of sine inverse. Now we can take the derivative of both sides. To find the derivative of sine of y, we'll have to use chain rule, with the outer function being sine and the inner function y. The derivative of the outer function would be cosine. And then we have to multiply this with the derivative of the inner function, which would be dy dx. And on the other side of the equal sign, the derivative of x is 1. Next, we can divide both sides of the equal sign by cosine of y, and that'll give us dy dx equals 1 divided by cosine of y. We've solved for dy dx, but our answer is in terms of y. The original problem was in terms of x. The next few steps, we're going to try to replace the cosine of y with something in terms of x. And to do that, we're going to use this line that we created earlier. Sine of y is equal to x. And we're going to do quite a bit of work off to the side, so I'm going to call this side work. So we know that sine of y is equal to x. Anything inside of your trig function, you want to treat that as an angle. And then whatever sine of y is equal to, make this into a fraction. The numerator would be the opposite side of a right triangle, and the denominator would be the hypotenuse. So let's make a right triangle out of that. Our angle is y, so I'll place that here on the left. We defined x to be the opposite side, so that will go on to the opposite side from the angle y. And the hypotenuse is the denominator, and that was 1. Let's call the bottom side here a, which is the adjacent side. Pythagorean theorem says that the two legs of a right triangle, in this case a and x, if you square both of these, that would be equal to the square of the hypotenuse. So a squared plus x squared is equal to 1 squared. To solve for a, we first need to move the x squared to the other side of the equal sign. And then we can take the square root of both sides. That leaves us with a is equal to plus or minus square root of 1 minus x squared. Here we're only going to consider the positive. Square root of 1 minus x squared. Our goal is to try to figure out another way to write cosine of y. And to find the cosine of y, we're going to use this right triangle that we now have completed. Cosine is equal to the adjacent divided by the hypotenuse. So for our triangle, cosine of y would equal the adjacent, which is the square root of 1 minus x squared, divided by the hypotenuse, which is 1. And that would leave us with the square root of 1 minus x squared. And so we can replace the cosine of y with the square root of 1 minus x squared. That means that dy dx would be equal to 1 divided by the square root of 1 minus x squared. The general form for the derivative of sine inverse for x uses a u as a replacement for a function of x. The derivative of this is then the derivative of u divided by the square root of 1 minus u squared. You would use this general form if what's inside of your sine inverse was something a little bit more complicated than an x. While it's important to know how to derive these functions on your own, it is far faster to have the derivative of inverse trig functions memorized. If you're looking for the derivative of cosine inverse of x, just use cosine inverse of u, and then the derivative of that would be negative du dx divided by the square root of 1 minus u squared. The only difference between sine inverse and cosine inverse is that the derivative for cosine inverse is negative, while the derivative for sine inverse is positive. The derivative for tan inverse of u is equal to du dx over 1 plus u squared. Notice for tan inverse, the derivative has no square root in it, and you're adding 1 and u squared instead of subtracting. Next up, we have the derivatives of secant inverse and cosecant inverse. The derivative of secant inverse is du dx over the absolute value of u times the square root of u squared minus 1. The terms inside of the radical are flipped versus the derivative of sine inverse and cosine inverse, and also they have a square root of u on the outside. And finally, the derivative of cotan inverse is equal to negative du dx over 1 plus u squared. Notice this is similar to the derivative of tan inverse, except now our fraction is negative. Since all of our tests and quizzes this semester are open book, you won't have to have these memorized in order to do well in the class, but for the AP exam, you will have to have these memorized. In the next video, I'll show you how to apply these formulas to find the derivative of trig inverse functions.